Okay, scale factors then. So we use scale factors in a form of ratio. So scale factors we use to increase or decrease, I'm just going to write that underneath, decrease a 2D shape. Okay, so we know usually on a scale, we have a scale on a ruler, don't we? Yeah, and it goes up in even amounts, yeah, or goes down in even amounts. And that's kind of what we're using with a scale factor here. So, so your task today, start off very similar to this one. Okay, so you've got a rectangle there. You've been given two sides measurements. Okay, so what we want to do, yeah, is to increase it by a scale factor of 2. Okay, which means it is 2 times the size of this one. All right, so and that's a very kind of nice calculation to make then. So, yeah, because if it's 2 times the size, you're going to multiply the size by 2 to work it out. All right, so we're going to do the vertical first. 3 centimeters times 2. Okay, which equals 6. And then this side, so 5 centimeters increased by a scale factor of 2, so 5 centimeters times 2 equals 10 centimeters. Okay, so if we increase that, I'm not going to draw it out again because I haven't really got the space, but if you see on here, you've kind of given the bigger square and you just need to find the missing sides, calculate the sides again. Okay. So, and you would just write those in next to it. So this would become 6 centimeters. That would become 10 centimeters. Okay, and that's increased by a scale factor of 2. Okay, well, what about a scale factor of 3 then? Well, we just work up the scale. So we multiply them by 3. So scale factor 3. This time we've got 3 times 3 centimetre, which is 9 centimetres, and 5 times 3, which is equal to 15. Okay, so this time, this one would be 15 centimetres, and this vertical would now be 9 centimetres. Okay, it's all a little bit jumbled up there. It's just, if I draw it down here. Okay, you're not asked to draw them today. Yeah, we're not all in year 6 at the moment, or for these, but we're just asked to fill in the missing sides. Okay, so scale factor 3, that would be 15 centimetres. There we go, from 5 to 15, 3 to 9. And that's being increased by the scale factor of 3. I think we go with 4, 5, and so on. All right. Now, in the same way that you've been given your measurements, and then you've increased them, it is then also possible to decrease them if you're given certain measurements, and it depends how the question is phrased. Okay, and if you look on your second one today, you have a measurement of 3 centimetres on one side, but nothing else given on the rectangle. But on the one that's been scaled up, scale factor 3, you've been given 15. Okay, so you can work between 2. This one needs to be increased by 3. This needs to be decreased by 3. And what we're going to obviously do there is 15. It's a bit like this one actually. Then we're going to do 15. So, and a scale factor 3 on that question. So you're going to multiply the 3 by 3 to get that side here. But you're going to have to decrease that. So divide it by 3. So you had 15 centimetres. You can divide it by 3. Okay, to get to the smaller shape. Okay, and I've set that up because when you do your, I think it's a challenge today, there's some triangles and some various different shapes. You can do it for any 3D shape, 2D shape with straight sides. Yeah, you can scale it up and then scale it down. So what I've done, we had a triangle 15 centimetres on that side. It's an isosceles triangle, and 9 centimetres along the base. Okay, and I'm gonna say that you've been told that was already increased by a scale factor of 3. So that's been increased. So now what would the measurements be on the smaller side, on the smaller triangle? Okay, that's the one that's been increased. So what will the measurements be for this one? Well, then we do the inverse. We just need to divide by 3 again. Okay. It's going to divide by 3. And 9 centimetres divided by 3. We know our 3 times table quite well. So 15 divided by 3 is 5. So that's that longer side. And the base, 9 centimetres by 3 is 3. Okay. Alright, so on this bottom, just be careful on this bottom one. Yeah, you've got, it's set out with 6 centimetres there. I've managed to put a mark over, but remember these lines mean that the sides are the same length. Okay, so you've got 3 sides at the same length. I will let you think to yourself, what type of triangle is that has 3 sides that are all equal? Is my little clue. But this time you've been given scale factor 4 and this triangle is smaller. Okay, so you're decreasing it by 4, which will mean 6 divided by 4, not whole numbers then, so you're going into decimals, but I mean, not very difficult ones. All right, so give those a go, and good luck with these. Enjoy.